Hi, everybody. If you weren't expecting a talk and you're disappointed, I'm sorry, I'm kidding. Hi, my name's Djirdeh, and I am a software engineer at Google. My talk today will be covering how my team in Google Chrome has been collaborating with Nuxt to optimize third-party loading in the framework. To give you all some context of the work that we do, I work in a team called Chrome Aurora, and our mission is to advance the web framework ecosystem by introducing better tooling and improved defaults to popular JavaScript frameworks and libraries. We've been collaborating with the Nuxt team for quite some time, and we share a common high-level objective. How can we improve both developer and user experience in the framework? Working towards this objective, we've helped ship multiple utilities, including the Nuxt image module, the Google Fonts module, and now a module specifically around third parties. You may be wondering how or why a new framework module is being built to improve third-party loading. And that's a fair question. We'll dig into that, but we'll start with a bit of background first. What are we referring to exactly when we say third parties? The HTTP Web Almanac defines a third party as an entity outside the primary site-user relationship. You can think of a third-party resource being sort of anything that involves the aspects of the site that is not directly within control of the site owner, but has been included with their approval. And third parties come in all shapes and sizes, from ads, analytics, to content embeds, chat, marketing widgets, and the list goes on and on. The third-party ecosystem is a massive one that makes so many developers' lives easier by not having to reinvent so many common use cases. In the Chrome Aurora team, we try to pinpoint the biggest performance issues affecting the web. On the topic of third parties, we wanted to see if we could correlate the number of third parties on a site with overall site performance. We'll start with largest contentful paint. It's a useful core vital metric that measures the time it takes to render the largest image or text block in the viewport. After a ton of research, it was determined that a good LCP score is 2.5 seconds or less. Okay, so how does the number of third parties that load in, say, a Nuxt site relate to LCP? Using data from HTTP Archive and Chrome User Experience Report, and we're looking at a sample size of about 90,000 Nuxt sites here, we can see that sites that load at least a single third-party resource, about 36% of them have good LCP scores. But when we filter the subset down to sites that load at least 5 or at least 10, the number goes down significantly. You can see sites that load at least 50 third parties, only 1% of them have a good LCP score. Let's look at another performance metric, interaction to Next Paint, which measures responsiveness by calculating all click, tap, and keyboard interaction latencies across the lifecycle of a page. A good IMP score is 200 milliseconds or less. We see a very similar looking chart when we try to correlate the number of third parties that load with IMP. Nuxt sites that load more third parties have poorer performance when it comes to responsiveness. It's important to mention that this trend is not specific to the Nuxt ecosystem, and we see this across the entire web. The more third parties that load in a cohort of sites, the worse their collective user experience becomes. It's really important to quickly mention that correlation does not necessarily mean causation. So we can't just look at the previous charts and say for a fact that it was due to third-party resources that caused a decline in their performance. But when we couple that with so many studies that we've done in the past, it becomes clear that third-party resources do have a significant negative impact on page performance. When it comes to third parties, and if we think of it at a very high level, we can sort of break it down into two problems: user experience and developer experience. Let's talk about user experience first. This right here is a YouTube video I came across, which is a very canonical example of a Nuxt developer doing a workaround to reduce the performance impact of third parties. In the title of the YouTube video, he mentions that you can make your website faster by removing Google Analytics, the script itself, and through a different approach, still get metrics from the provider. If you actually watch the video, you'll see that he's done a pretty smart and interesting thing to make this possible. He's directly sending events to the Google Analytics Collect API, so he doesn't have to include that entire 70 kilobyte script. It's a pretty smart technique, but one that the Google Analytics team does not recommend because there can be a lot of unexpected behaviors and breaking changes. The reason I bring this up is that this is a good example of someone spending their valuable time to make a third-party script load faster when they would have likely preferred to use their time to work on their own features. And similarly, we can also find examples of Nuxt developers that struggle with figuring out how to even include third parties in their application. In this GitHub issue, for example, the user asks if anyone has even mentioned to figure out how do you even place Tag Manager or analytics code to a Nuxt 3 project. Again, this isn't something we've only noticed in the Nuxt ecosystem. We've seen this in many other framework communities as well. So how do we solve these common issues? With regards to user experience, can we not just improve the performance of code provided by the third parties themselves? It's a good question, and for some we can, but this can take years. Many third parties are used in millions of websites and to make third parties easier to manage and more efficient. We'll start with the use script composable, which is part of the unhead library. The core packages in the library can actually be used in any framework, and there are view integration wrappers already available. Use script in particular is a neat lower-level API that makes it easier to manage third-party scripts in an application. You can choose between different loading strategies, like idle or manual, or even pass in a promise. And you can also resolve the script API and assign any global variables. You also have the option to stub out any logic and handle how the script is handled in other environments, like during server-side rendering, for example. Although useScript is pretty cool, like I mentioned, it's intended to be a lower-level API used in higher-order utilities. We're working on one right now called Use Google Analytics that makes it easier and faster to load Google Analytics. The parent composable leverages useScript under the hood, which makes it possible for us to take advantage of its building blocks, like the script wait for load promise that makes it easier for anyone to send any custom events once the script has finished loading. We're working on the same type of thing as well, but for Google Tag Manager, a use Google Tag Manager composable. You probably see a pattern here, a higher order function that makes it straightforward to instantiate, and then useful utilities that are optional to use for certain scenarios, like sending events. The nice thing about building out a custom module is that we're not only limited to composables for scripts. We also have the option to provide wrapper components to make it easier to load embeds in a vetted way. Like Google Maps, for instance. We're working on providing an out-of-the-box component that uses their JavaScript API, and we're also looking at ways of improving its default performance right out of the box. And another component we're working on as well is one that displays a YouTube embed. This one is a good example of a component where we've already baked in a performance optimization right out of the gate. And in this one, we decided to use Light YouTube Embed, an open-source web component built by a Chrome engineer as well that loads significantly faster than a native YouTube embed. You can see an example of how much faster in this GIF, which was an experiment throttled on mobile to a 4G connection. I hope this all was just a nice teaser of what we've been working on. We're constantly exploring different techniques and already thinking about what other third parties we plan on supporting. The work that I shared today will likely be released in about a week, and we're wrapping up the documentation right now, so I recommend keeping an eye out for when it ships. The last thing I want to say before I conclude the talk is that all the work that I just shared right now isn't something that I worked on at the development level. I'm just a messenger, and I'm just standing on the shoulders of giants. The Nuxt team have been an absolute pleasure to work with, and I'd like to shout out Harlan, Julian, and Daniel in particular for working so closely with us while being so busy with other endeavors. And on the Chrome Aurora side, Thorsten on my team drove all of the development, and we wouldn't be where we are today without Kara's and Ralph's contributions as well. I hope you enjoyed this talk. Again, a nice little teaser. Once we ship, I'd love to hear feedback. Please go on GitHub, send issues, discussions. The more feedback, the better. Thank you, everyone.